All right, I think we're going to go ahead and get started. My name is Dave Conacher. I'm the president of Ecologic Analytics, and I get the esteemed pleasure to introduce my new best friend, who I've known for, 24 hours now, John?
At least.
Sincerely, great partnerships start with great customers, and I couldn't say more about what Oncor has done. And he's going to go through the AMI integration to OMS, and he's going to kind of talk about the collaboration between IBM, Landis & Gear, and of course Oncor. So I won't keep you waiting any longer, but I'd like to introduce John Pettit, please.
Thank you, Dave. So I'm from Dallas. Dallas, Texas is where our corporate headquarters, so I have to say howdy to everybody. You haven't heard that yet. You know, this is such a cozy little audience. I want to just come up here and go, my name is John Pettit, and I'm an IBM customer. So first thing I want to do is talk about Oncor in general. So Oncor is the 6th largest T&D company in the U.S. Now in Texas we are deregulated, and I've got a picture for that. But we just finished our AMI, or in Texas we call it AMS because we have to be different. Our AMS deployment we finished in December. I think I have 3.25 million plus meters deployed, advanced meters. Now in our case in Texas, the requirements of those meters were specified. So we actually do 15-minute interval data. We have a Zigbee hand chip in all the self-contained meters and some of the other three-phase meters. We use disconnect switch on all self-contained meters, and we actually do about 300 to 350,000 remote switch operations and remote reads every month. So we've been done, I think the count was 4.5 million we've done, and so every one of those was a saved truck roll. So Texas is a deregulated market, and we are one of 4 major T&D companies in Texas. As you saw in the picture before, we cover about a third of Texas, 7 million people out of the 23 or 25 million in Texas. So we have a competitive generation market, and we have a competitive retail market. We have about 100 plus retail electric providers or competitive retailers that we deal with, of which there's probably a half dozen to a dozen that are actually large market, large players in the retail market. So our simplified IT diagram, back in 2008 we started our AMI deployment, and we added a lot of new systems. With IBM as our system integrator, we have Landis & Gear is our Landis & Gear Gridstream system for our mesh, also for all of our meters. We use the command center head end. We use the Ecologic Analytics, now Landis & Gear MDMS. We use Maximo is our asset management system. That was an enterprise solution. We use it for transmission. We use it for distribution. Now we use it for metering. We also have, there's some other components in here that aren't as important. But with this, at the same time we were building AMI, we were building an OMS system. And the OMS system is underlying is a Siemens, the DMS systems, and then the operator GUI is a Intergraph solution. So basically what happened is, I think it was back in early 2011, one of our executives had an interview or did something, and now we knew it was going to happen, but basically he said, yes, we're going to integrate AMS to OMS, and so at that point it officially became a project and we had to do it. So we did this in about a little bit over a year, and I'm going to show you some of the results of that. So as expected, normally we've got our normal AMI systems. I talked about the home area network, or a little operator error here. So we have our normal home area network to the meter, the RF mesh head-end system with Landis & Gear, MDMS. We have a legacy CIS system that's currently being replaced, but it's an ancient squirrel-driven customer one system that's been heavily customized. We have a data warehouse and operational data stores, our AMS Maximo, as I mentioned, and also we have an internal portal that's used in several cases, and in fact it's used in our OMS where the operators can actually go in and ping a meter individually. So with that, we also have a common web portal that is common with the market, and that's also a common data repository, and that's where all of our 15-minute interval data goes. Now, the 15-minute interval data is used for settlement, and the retailers have that data available to send to their customers and bill off of it, along with ERCOT, who's our ISO. So since last year, March 2012, we had our plan in place, and deployment was going to originally start with small districts and just release them a little bit at a time. What we found, though, as soon as we started doing this, the operators suddenly realized that this was a useful tool. And so we essentially accelerated the plan and essentially put the whole system into service much sooner than we expected. So within this plan, one of the key components is, with the integration, is the smart data for outage management, the outage management module that's part of the MDMS. This is an added, this is the extension on it, and what it does, it basically, that outage module extension keeps track of everything that's happened on the AMI system. So it knows all the meter statuses. It has a basic network model that keeps track of what transformer that's assigned to, and then it talks to the OMS system that knows the status of all the transformers and up. So some of the things we've done with AMS OMS is, the key here is that we've had outages that are as large as 500,000 endpoints at once. And we knew that would be probably overwhelming to the OMS system. So this outage module does a filtering for us, and essentially it looks at when an outage occurs, it cuts down the outage to 2 endpoints, and it blocks everything else, and it sends that transformer information to the OMS. Therefore, the OMS knows that, hey, this transformer is out of service, and then anything else that occurs on that transformer is blocked. So it limits the data that flows back and forth. It also looks at what the OMS says, and the OMS will tell us that there's a feeder level outage or another distribution piece of equipment that says, hey, all these endpoints are also out of service, and it blocks that, and it tells the outage module says, don't send me anything about those devices, I already know. And so that it does that filtering level. As I mentioned, we don't do single meter outages. Single meter outages are something that's in our future to figure out how we're going to use those, but it was something that we didn't want to contend with at this time. That's a future state. So the operators, as a restoration occurs, one of the good things is the operator has the ability to go validate that the system is back in service. We also have it if a customer calls, the operator can go to the system, validate that, yes, customer, it is truly on our side of the problem, or no, I'm afraid you have a customer problem, you need to check your breakers, et cetera. And so we actually save a lot of truck rolls with this system. The validation has been excellent. Mark Carpenter yesterday talked about how 20% or 23% of our outages now are actually worked before a customer even calls in. And what that's done for our 5 to 7 p.m. Call center call volume, it's decreased to almost nothing. So the operators have the ability to control the system. If they suspect that there's a major storm brewing, there's a good chance they're going to turn the system off, because at that point, there's a trade-off between last gasp messages and power restore messages. There's a trade-off when you have a large storm. You don't care as much as when the power goes out. You want to know to get the power back in service. So we have the ability for the operators to turn that off. They can actually do it by district if they want to. Otherwise, they can kill the whole system. We also have some controls on the system. If the amount of transactions increase too much, then that can also be cut off. It will automatically shut the system down. We also have the ability to do a mass ping. One thing the operators have found is very helpful. If there's a suspected or nested outages, they can actually take a list of meters or a list of endpoints and dump them into the system, and it will respond typically within 4 minutes. 80-90% of the message will come back, and they'll know that the current status of the system. So obviously timing's a factor. We have a 40-second timer that's on the meter. That's at the meter level. We have a supercapacitor that retains that information. We found that 30 seconds was an issue because some of the under voltage reclosers were set at 30 seconds, and we have some races in some cases. So we've done a system-wide setting at 40 seconds at this time. There's also a almost 3-minute timer momentary outage filter, just in case it is a temporary filter. So then we get another outage on the load, on that transformer, that load transformer, within 2 minutes, and all the other criteria meets. That's when the signal goes. So urban legend, and this was something that came out of the operators. It came out of a lot of people on the operations side, is that AMI, the last gasp, is always giving false messages. It's always telling us that there's problems with the meter, obviously, right? But what we found is that in most cases, those false outages were indicating that there's a problem with the secondary. So we actually had crews assigned to look into this, and they found that in most cases there was a loop termination, hotspot on a transformer, something that was causing an issue. And in a long term, it would be a real outage, but it gives us a chance to proactively go out and fix that before the customer even notices it. The key here, trust the data. If you've got a piece of equipment out there that's giving you a signal, it's telling you something, there's going to be some truth to it. It knows there's a problem. You just got to figure out what it means. So some of the lessons learned. I talked about the 30 seconds. Last gasp and power restores, you're not going to get those all the time. You lose power in a large area, there's a very chance that that last gasp is not going to make it up the chain. It's something that you just can't expect that. So you build that and anticipate that. You put that in your assumptions in your model. Distribution network. With our OMS project, we walked down most of our system and we validated most of the transformer loads. You know, we're still finding, you still get an occasional cross meter or another issue, but that's something you have to just be prepared to fix. We do a weekly sync with our network model to the outage module once a week, but it gives us a chance for the operators to get the reports in, fix the data as it occurs. Of course, the one thing, people will move your meters for you without you asking them. That's always one of those happy things that you always know about. So those meters will move. I mentioned it before, the bigger the storm, the less you care about the outages. If it's a clear day, then you care about the outages to lead to restoration. Operators. Operators are a special breed. When you first initiate change to them, especially in a company like ours, when the operators are, the average age is, in most cases, even older than I am, the operators will be real hesitant about change. You first put a system in service. We used to take that system out anytime the clouds formed. We went along farther and farther, and we've finally come to the point we leave it on. Let it run. We actually had with the exception of IT maintenance outages, when we request it now, we've actually had the operators say, no, you can't take it out of service. We've got a small storm coming. Don't touch it. You need to put off your IT install until the following day. So they get where they are dependent on the system because it really does work. And that's the big thing here. This is not our future sky prediction. This is a system that does work. So what are the next things that we're going to do? I talked about the false outages and making sure the crews understand when they see those outages, let someone know. Try to figure out what the problem is. Research it. Find somebody to research that. Single premise outage, what do we do with that? Obviously, we need to address that, especially on a day like it always seems to be here in San Diego when it's clear. When you get those onesie, twosie outages, you've got to address them because those customers may or may not call in. Connectivity data model, I mentioned that. You've got to continually tweak that system, make improvements to it. Let me see. And I suppose that's about it. So that was quick. So what kind of questions? It was a little bit over a year. By the time we decided to do it and we actually got the project spun up, it was a little bit over a year. It was early 2011, and we put it in service in March of 2012.
Can you explain, you said you were going to really roll it out in a fairly deliberate, slower
Yes.
way. Then all of a sudden, after the first steps you took, it seemed pretty good.
Yes.
It gave you the confidence it gave, I guess.
The operators.
Confidence, more importantly. Faster. Do you know why that is? Why
Well,
it turned out better than you had imagined?
you know, with any big project like this, there's always some suspect that something's going to go wrong. Even with IBM, I mean, but when we started rolling it out, we had this gradual, let's do this region, you know, by geography. And we started doing it, and those areas started seeing those small storms come in. And we saw how effective it was, and we finally came to a point, and they just said, just turn it on. Come middle last summer, just turn it all on. And essentially, we really haven't taken it out of service since then. Yeah, it was a surprise to, okay, it wasn't a surprise to IBM, but it's a surprise to us. System works quite well.
What future analytics are you thinking about adding?
That's a good question. You know, with AMI being deployed and our OMS tied together, I think that's our next phase in the project. We've got a lot of projects coming in, voltage control, capacitor bank monitoring control, tampering detection. We have a lot of manual things we do now, and automating that is the next thing. So we're just now trying to figure out what we do next with it. So the analytics is, and everybody talks about it, the big analytics. You know, we have our 100 terabytes of data or whatever we have that we need to start using it. We just now made the data accessible to essentially anybody in the company that wants it through our data warehouse. So we're just now getting to that point where we've got to figure out what's next.
Are you involving the customers through social media and things of that nature?
Yes and no. I mean, they have access to outage maps, and they have access to SMS and text. But remember, as a T&D only company, we don't really own the customer. Now, if we have an outage, of course, the retailer goes, call Oncor, but it's kind of a different environment. We are prohibited from doing any competitive energy service. So if it's seen as something competitive, then we have to get dispensation from the commission to actually do that. So for our hand pilots, we had to get something that said, you are allowed to do a hand pilot of X number. And so it's a fine line that we do, that trade-off between our customer, which is really the retailer, and the rep's customer. So we're the enabler. In this case, we like to call ourselves the FedEx or the UPS of the electricity world.